Greetings and welcome to our 9th test and measurement video. We'll take a second look at the Keysight Technologies, formerly Agilent, MSO X4054A oscilloscope. It's a 500 MHz, 4-channel, 5GS AS instrument. Today we're going to pick up a utility 60 Hz, 120 volt, single-phase power feed from a premises branch circuit, displaying it on the oscilloscope screen in the time domain, translate it into the frequency domain, and finally show the two domains simultaneously. Starting at the beginning, we want to access the utility voltage in a way that won't endanger the oscilloscope, the user, or visitors. Of necessity, energized bare metal wires or terminals have to be available so that a probe can be connected. Obviously, there are possibilities of shock, arc flash injury, and electrical fire. The power cord has to plug at one end into a receptacle. The first line of defense is to keep the cord unplugged when not in use and store it in a safe place. At the output end of the power cord, a good way to isolate the hot and neutral wires from each other and from human contact is to enclose them in a plastic surface mount wall box. Cut the green equipment grounding wire short so it is not in the way and so that it won't contact the hot wire. Make the white and black conductors different lengths so that they cannot contact one another. Strip off the minimum amount of insulation from these two wires to minimize exposure. 1/4 inch copper is all you need to connect the probe. Use a hook end for the probe tip. It is essential to avoid sparks and smoke that when using a grounded bench model oscilloscope, the ground reference lead is not to be attached to anything referenced to and floating above ground. Therefore, always connect the probe tip to the black wire and the ground reference lead to the white wire. This presupposes, of course, that the wires have not been misterminated in the power cord, the receptacle, or anywhere back to the building's electrical service. We have connected the probe to channel 1 of the Keysight instrument. First, we'll bring everything back to default setup. In most oscilloscopes, including this Keysight 4000 series, only channel 1 is active following a default setup. All other channels are off. To display the 60 Hz utility power, we'll push Auto Set. There's the sine wave. Right now, there are no significant irregularities, probably because there are no heavier nonlinear loads that are in close electrical proximity. We'll take a look at the frequency domain. Press Math. Then press the soft key corresponding to Operator. Move to FFT, which stands for Fast Fourier Transform. Then press Display Math several times until the frequency domain appears. Notice that virtually all the power is represented by the huge spike on the left. The reason that it is not at the center with two sidebands, as shown in textbooks, is that the oscilloscope does not display negative frequencies. The odd-looking part of the trace at the bottom is the noise floor. You're seeing random motion of electrons in the oscilloscope components and circuitry. Thanks for watching. In the next video, look for another oscilloscope demonstration illustrating the Keysight MSO X4054A onboard demos.